So T.Rex Arms does a lot of things. We sell a lot of stuff, we develop a lot of stuff, but it all started with holsters. We've been making holsters the longest, and they're still probably the most important part of our business at accomplishing our mission. And every holster begins as a flat piece of Kydex. And the beginning of the process is that this thing needs heat. Now, when Lucas first started making holsters heating Kydex, he used this toaster oven. But pretty soon we realized that t-shirt presses are the way to go. Something that applies pressure to the Kydex and has contact. Now, most t-shirt presses only heat from the top, and we modified them so they get heat from the bottom, and eventually we found these off the shelf that have heaters in the top and bottom. But they still have some issues. Number one, the temperature is sort of variable, and we want something that is more precise. Also, there's a lot of up and down motion to actually use these things. They take up a lot of table space for something that only holds one piece of Kydex, and then when you leave them open, they kind of blast heat into the entire shop. So we thought that we could come up with something better. And we also would like something that is smarter. As we've added more sensors to the vacuum forming and cooling process, we'd like to log some of our heating cycles as well. Oh, and then we have a couple of different thicknesses of Kydex that you have to adjust the pressure here in between each one. Ideally, we could solve all of these problems in a single new tool design. So we wrote up a gigantic wish list, and then we made this prototype, which is an extremely complex system that tries to address every single thing that we want to accomplish. This is going to be the most complicated thing that we have ever built at T.Rex. Now, there's an added layer of complexity here, because we're not making one of these things, we're actually making 8 for 4 different molding stations, and the prototype can be our spare, because we've learned that you always need a spare. So, why is it that we're building 8 pretty complicated machines in-house when we, as a manufacturing facility, bend plastic? Well, the answer is that we have a very capable and fairly sophisticated engineering department. And even though we've never built anything remotely this complicated in-house, all the internals, all the bits and pieces, all the stepping stones inside of this machine here are things that we have experimented with, tested, proven out, and, well, learned how to do. There are several tools in our toolbox that have made something like this possible, and explain why we want to do something like this ourselves. So T.Rex hasn't always had advanced automation tooling. We haven't always had an engineering department that can build stuff like that. Everything used to be handcrafted, and that was kind of before you were here, Pete, but you did visit. Yes. When we did a bunch of handcrafting, and you are no stranger to handcrafting yourself.
I've been handcrafting a lot of things for a long time.
Yeah.
And it's a very rewarding process.
Rewarding?
So it is rewarding.
Fulfilling?
It's a question of, like, can you do it? You know,
yeah.
What does it take to do it? And a lot of trial and error, which is a satisfying process. Mm-hmm. You know,
but there's downsides.
There is downsides, absolutely. So while the numbers are really low, and you know, while the tolerances aren't as important.
Yeah, when you can still just like glue HDPE to glue guns.
Absolutely.
And make it work.
The crafting process is incredibly fulfilling as a process to the person who's making it, and the challenge of, can I do it?
Yes.
Will it work out? And then when it does work out, you're really excited about it.
It's the best feeling, yeah.
And then it's even better when someone else comes along and says, I like your product. And your product is something that, you know, I'm as excited about as you are after having made it.
Yeah.
And so
then they want 5.
Then they want 5.
Then they want 10.
And that's exciting too, because you're starting to get traction. Things are happening.
Yeah.
And then when it becomes 10 and 20, it's even more exciting until 9 p.m. kicks in and your dinner goes cold.
Then you start to think less about handcrafting and more about mass production, yes, and automation.
And then it gets more exciting than handcrafting, because you get to do both.
Yeah.
And so that's really neat. So handcrafting is very much a an emotional process, a technical process.
Yep.
It's a personal process.
Artisanal, handcrafted, organic, free-range holsters. Yeah.
Right. So when you get like some of my peers of furniture makers, they would check if the surf's up. They go surfing first, then they get the best coffee they can get, go out into the shop in the afternoon and make the most incredible dining tables and things. That's a lifestyle, and a nice lifestyle, a good lifestyle. But when the orders kick in to 10, 20, 30, 50, 100, you have to transition.
If your mission is to equip serious citizens,
absolutely,
not just put food on the table and make a table every other week.
Right.
It's a little different.
Absolutely.
So that's where we are at T.Rex. We've gone from handcrafting to mass production with the wrinkle of made to order.
Right, and these are some of the original templates.
Yeah, because we did want consistency, so we made templates.
These were not stylist-driven templates. These were
hand
pencil-driven.
Followed. Yeah.
Templates.
We had templates because we did want consistency, but now we're at the point where the orders are more than 10 and 20. Right. Significant tooling needs to come in, and we've added a bunch of tools to our toolbox that make that possible.
Absolutely.
That's where you come in.
That's where we come in. And so then it's all about taking away the variables, because variables slow you down. It does not provide what the serious citizen needs with consistency and reliability and a product which they can count on working in a very specific way. And every variable you have is one less holster you can make, because you've got to overcome that variable.
Every mistake you have to repair is another holster that you can't give to somebody.
The role of engineering is to just take out every variable you can. And that makes speed, and speed is what manufacturing is.
So we've gone from handcrafted holsters to automated holsters. And I think that we picked most of the low-hanging fruit. We've taken a huge amount of variables out of the cutting process, out of the bending process. Heating is kind of our last thing, and it's been complicated to solve. There's a bunch of stuff we had to figure out before we even had the tools to build the heat presses. So I think we've narrowed it down to 7. The first one I want to talk about is proper CAD design software.
So there's CAD to actually verify that all your parts are going to go together correctly. Yep. To be able to take an object and digitally make it transparent, so you can see the inside of a surface at the same time as you see the external surface, or intersections of two parts that have to merge. Switching between cross sections and transparencies are just two factors right there on their own, which is something that I don't think they could have done 50, 60 years ago.
I think you had to do it in your brain. So I think what CAD actually does is lets inferior engineers see what superior engineers were able to think through in the past.
A lot of things happened pre-CAD, really extraordinary things.
Yeah, battleships, aircraft carriers, supersonic jet fighters, all kinds of stuff.
2 world wars worth of industry was built without CAD, which is absolutely incredible. Very worth another episode, I must say. Hint, hint.
Yes, yeah. But once you have CAD, once you have the ability to collaboratively build in the computer with other people, you have the ability to test stuff in the computer, but you also have the ability to send stuff straight to those milling machines. Yes. Start cutting those parts out without interstitial manual steps.
The efficiency is just exponentially greater.
Yeah. So here's a finished part direct from CAD to finished aluminum. So, Pete, what can you tell us about the Haas machine? This is the DT2. This feels like our second giant leap into proper engineering department capability. Actually making our own metal parts with a high degree of precision in-house.
It has been a big leap because it allows us to develop the tooling which takes all the variables out of the process.
Yeah.
And to be able to do that in-house is super fast and allows you to develop what you're doing and why you're doing it and how you're doing it.
Yeah. So this Haas machine is the same thing that we're using to make holsters, and there's been a bunch of automation implemented inside of those. But for this, you're only making so many parts for our vacuum forming stations and the new heat presses. It's not enough parts to count as mass production, so It looks like you're still doing a lot of manual setup type stuff.
Yes, a typical run might be only 20 parts.
Yeah.
So it might take an hour or so to dial in what you want, and then you're good to go. It might be all over in 15 minutes.
Yeah. So this is a relatively simple frame for one of the vacuum formers, and I've seen you build most of the parts for this, but I wasn't here when you did this. I'm kind of in awe of just like what a complex part this is compared to the stuff that we used to make out of HDPE and deck screws.
That was in 2 steps. It's a little cable management fixture which goes into Bosch track, so we can restrain these hoses and cords and different things, so that none of the moving parts can get in the way.
Yeah, which brings me to the next thing that I don't want to say mastered, but once we understood pneumatics inside of T.Rex, which was slightly before you arrived, a whole new world of possibilities opened up. Now, I did not have a background in engineering, and so I learned about pneumatics probably with a Lego Technic set when I was a little kid, but I never thought about it again until we needed to solve some problems with T.Rex. We already had some equipment that required air compressors, and we already had plumbed part of the shop for air, so it was kind of a no-brainer to research pneumatic cylinders and use them, and I just can't tell you what a fantastic tool they are. When you need consistent linear motion, they are just the best. So every single one of these sidecar bending jigs right here has a single cylinder, 2 stages. The hoses are color coded, which is something that I love. And with a foot pedal, it opens, jig goes in, it closes. It's simple, it's straightforward. There's a regulator that lets us adjust pressure if that's something that we need to do. And then it's a super simple electrical circuit to run the solenoid that opens and closes the thing. Another point I want to make is that all of these tools are cumulative. We were making holsters with pneumatic tools and solenoids and things back in the old deck screws and HDPE days. But once we had the ability to cut aluminum parts and design them in CAD, we got so much more bang for our buck. Proper parts plus pneumatics is way more than just pneumatics by itself, even though I will say we still use the deck screws for different things here and there along the way. But once we started to mess around with pneumatics, we started to need to learn to do electrical stuff. Actually, the first electrical circuit we set up on our own was for vacuum forming, and it was a simple solenoid that opened the vacuum, but it's the exact same principle for the compressed air. And well, once we get to the new heat presses, I'll admit things got slightly out of control. So, Bryce, I have to tell you, you have more experience in the actual engineering world than I do. As far as I'm concerned, this is an incredibly complicated system. As far as your experience goes, what would you say?
The reason it looks so complex is there's so much of it, but when you break it down, you have the high voltage components over here and the low voltage components over here with the PLC controls, and then terminal blocks that make all the connections. Like this is the where you like in a wire nuts in a house in a junction box. That's essentially.
Yeah, I love that we seem to have gotten our labeling under control for the first time.
Yes.
Which was necessary based on the number of connections. How many wires? How many connections do you actually have between your blocks, PLC, relays, and yeah, there's you know, I'm seeing a few connections here and there.
Certainly hundreds, if not over 1,000. I mean, there's definitely a lot of connections.
And we got some cables here. My favorite part of this is actually our little strain relief up here, which is 3D printed in-house to the exact specifications of the rail just because we could.
Absolutely.
You might think that the 3D printer is one of our superpowers here in the engineering department.
Yeah.
It's super handy, but I would say that being able to do this level of electrical engineering, admittedly very simple compared to a lot of things, the ability to do this in-house is a fantastic tool for our toolbox, because this is not new for you, but it's pretty new for T.Rex.
Yeah, I definitely agree, this is a big leap forward to be able to do this in-house.
Yeah. But in some ways, the complicated bit isn't all the wires. It is the brain right here, the PLC, which is something that we can also program in-house.
Right, correct. And that's a very important ability to be able to do that.
Yeah.
So this is more or less on the entry level end of a PLC, or very much so on the entry level end actually. It's not a Arduino, hobbyist Arduino or something, but it is about as cheap as you can go for an actual automation product. It's from Automation Direct, and they're very inexpensive.
Yeah.
They have limited features, but I think most automation doesn't use the fancy features and the super expensive stuff anyway.
We're calculating a lot of things, but it is pretty simple level of inputs and outputs. We're keeping the temperature at the right place. We're figuring out how thick the Kydex is. We're setting timers. And there's room. You got a lot more inputs and outputs here. There's a lot more processing power that we could do stuff with, but
Yep.
it's not. Why does it look so complicated if all we're doing is those few things?
Well, it's just a lot of wires. The cool thing about PLCs is they're made to be able to receive inputs and outputs from all kinds of different devices, not just devices that were made by the same company that's making the controller. And so, but the really neat thing about this is we're able to use the relays we want to use, the RTDs we want to use, the proximity sensors we're using to measure the thickness of the Kydex.
Yeah.
We can use all the parts we want to use.
Yeah.
So,
Very cool. How is it that you ended up being our PLC guy? Who tricked you into accepting this position? How did that happen?
it's actually really funny because I started using PLCs for just conveyor line controls earlier, just because it was easier than using relays. But that was like the first automation project we did with those.
Yeah. People watching this video are going to be in the comments talking about how dumb it is that all of the lessons that we have learned here at T.Rex over the last 10 years are things that industry figured out decades and decades ago.
Yes.
So we're not claiming to be pioneers of anything really, really groundbreaking here. We're just talking about what we have gradually figured out.
Yeah. So I was just tinkering on my own and kept running across this thing called a PLC. Finally Googled, what is a PLC, and realized that's what I should have been using.
Yeah.
So when stuff like this came up where the engineers needed some PLC work,
Yeah.
I was just able to help with that.
So it's a very cool thing that even though we have different departments here at T.Rex, the collaboration, like the fact that you are managing production, so you understand what is being done and what's needed by the heat press, but also can pitch in and do some of the advanced programming, makes the process, not just the feedback process of prototypes, but like the collaborative process of designing and building the product, I think work a lot smoother. There's also some brand new materials in here, and that may not sound like something that we've learned how to do. You can just pick fancy coatings like this Teflon from drop-down menus on websites, but you need to have some experience with the materials you're actually going to work with Kydex to know which coatings are actually going to work. And you need to have some production time with either the prototype or previous heat presses to know that you're going to need fancy calcium-based thermal shielding so that you can run this thing more comfortably and efficiently during high volume times like Black Friday. You got to have that previous experience and that baseline to build your design properly and spec out your goal. You could always hire brilliant CAD designers and brilliant electricians and brilliant PLC programmers that have no experience with this stuff. But ideally, you combine all of these things together. Work forwards from what it is that you've learned and backwards from your goal to actually arrive at your destination. So the very last tool in the toolbox is a lot less tangible than understanding electrical circuits, relays, PLC, stuff like that. I think that it is the way that we think about designing a process, the way that we think about iterating. We could have outsourced this thing. We could have written up a spec sheet, sent it off to a tool maker, and had it delivered in-house, but by building it in-house instead of just having it delivered, I think we learned a bunch more stuff. And what is it that enables you to actually learn from the process? Because I can also tell you, we could have stumbled along, done painful experiments, rebuilt stuff 3 times, and not learned anything.
Right.
That's doable too. So how do you iterate and troubleshoot and learn from your mistakes and improve the product?
Well, there's a couple of things that are interesting that you mentioned there. So you need to be able and willing to quickly and easily iterate within your design,
Yep.
like as in mentioned before, the DFMEA process.
Mm-hmm.
And you have to also be able to quickly and easily identify where it is your process is falling down. So your PFMEA process is important, because sometimes you have a great design and you don't realize it's your process that's letting you down. you know.
Yeah.
And sometimes it's a lousy design and your process is going great, but the concept is wrong.
Yeah.
And so when you outsource that to someone else, they'll make the part, they'll do what you want, but you may be asking for the wrong thing.
Yeah.
So by being involved on the shop floor, doing what you need to do, and having your hand on the job, you get a little bit of a sense and the ability to be in the driver's seat in that process.
Yeah.
And outsourcing is efficient once you know what it is you want.
Yep.
It's efficient if you're doing this multiple times, often.
Yeah.
But to learn what it is you want and which part of the process, whether it's the design issue or the process issue, is letting you down or showing you opportunities. It might not be letting you down. You might be doing something and you go, that is it. This is what we need to do.
Yeah.
Here is a home run right in front of us.
Yeah. I think that there's two things that are really key to this. And it is a combination of setting a goal and working backwards from the goal to figure out what's needed to achieve the goal. But it's also working forwards from our experience. We have 10 years, 11 years of working with Kydex now, and we understand Kydex well enough that we've been pretty able, I think, to isolate issues to the heating process. There was a time when holsters would come out bad. We didn't know if they were heated wrong, we didn't know if they were cooled wrong, we didn't know if they were molded wrong, we didn't know if they were bent wrong. Anything could have happened in any of those processes. But by tightening up all the different tolerances, you can narrow things down and get very specific on the problems that you're trying to solve.
It's really interesting you say that, because that makes me think of the whole design thinking process.
The mentality.
You know,
Yeah.
like 10 years ago, would you have thought that T.Rex was where it's at? You know, you can't really often see that far ahead, but you see the next couple of steps and maybe the third or fourth step with some clarity, but you see the immediate step very clearly. So as one of my favorite podcasters would say, do the next right thing. And that is often very clear. You get there and then you look back with the design thinking process, you look back and sort of say, was that successful? Did it take me forward like I thought it would? And then you're at a new place to look to the next step. And so generally it's a forward motion of thought and action, but there's always this circular process where you speculate and then you assess, and you speculate and you assess.
Yeah.
And that doesn't always seem a comfortable thing, because sometimes you feel like you're going backwards.
Right.
Or
Yeah.
just treading water. But in actual fact, it is the essence of the design process,
Yeah.
is to be willing to just try, assess, try, assess, try, assess.
And that is, I think, the most important tool that we have in our toolbox, because we can always figure out other mechanical means of doing things, but this ability to iterate the design level thinking is absolutely necessary. That's probably the reason people were able to build stuff without CAD.
Well,
60 years ago.
I think you just about hit on something I was going to say. I think maybe because those old casting shops and things were able to adjust patterns, cast patterns, dress patterns, maybe within the hour.
Yep.
You know, that's how they probably were able to make a lot of trial and error go
Yeah.
very, very quickly.
Yeah.
And the iteration process was probably actually really streamlined.
Yeah. I mean, it would need to be. And it's great that we've been able to put a bunch of that into the computer, but you still have to keep an awful lot of it in your head to build effective tools, pretty much at any scale.
Right. Yep. And the more you do it, the less turbulent and the more streamlined the process can be.
So this is the heat press project, and depending on whether you are an engineer, you think that this is a pitifully simple project that we've talked too much about, or maybe you're not an engineer and you wonder why we went into so much detail here. This is only one tool, but having learned more about some of the electrical, some of the pneumatics, some of the manufacturing, some of the materials, some of the process stuff, those are all tools that get to go into our toolbox, even if we stop using this sometime in the future. Now, this is a sort of a tricky balancing act. Custom tools like this don't really have any resale value. We can probably sell our heat presses on eBay when we're done with them for more than we could sell this for, because who knows whether this thing that is completely custom built actually fits anybody's needs. But if we have a hybrid approach where we have Haas machines and we use as many off-the-shelf parts as possible, we can kind of have the best of both worlds. We've learned more about existing tools, existing processes, materials, PLCs, etc., and we build a custom tool that does exactly what we want, and everything that we did along this step of the way taught us something. So hopefully this video has also taught you something. If you're an engineer, you didn't learn anything new about PLCs or cutting aluminum. If you are just a holster buyer, you probably didn't learn much about our internal processes that will necessarily help you make an informed decision about a Ragnarok or an Ironside. But hopefully this way of thinking about the process and the design, figuring out how to work backwards from your goals and forwards from the lessons that you've learned in the past, and add toolboxes, add tools to your toolbox as you go, is something that you can apply to your own job or your own company, whatever it is. At T.Rex, we want to equip people with tools like holsters that allow them to defend their lives and the lives of others. We also want to reinforce an idea that it's great to be able to make things and understand things. And so as we learn things, we learn how to make stuff better, we kind of want to keep you guys in the loop, even if we spend a lot of time talking about brand new pneumatic stuff, which personally I find fascinating. So Pete, eagle-eyed listeners might have noticed that you are not from these parts.
True.
The fact that you are here and the way that you got here is amazing, and the stuff that you did in Australia is also amazing. So keep an eye out for Pete on the T.Rex Talk podcast. We'll link to the channel. Not this coming week, but very, very soon. We're going to talk about that stuff.
Yep, let's do it.